A ratio is a comparison of two quantities. So the value of a ratio, A to B, is the number A over B as a fraction, which describes the multiplicative relationship between the quantities in the ratio. So let's see what this means. 2 snails to 6 fish, we can write that fraction as 2 over 6. Oftentimes we need to simplify this, so we go 1/3. What this means is that snails are 1/3 of the fish. Likewise, here we have 1/2 cup cream for every 1/4 cup, 1/2 cup milk for every 1/4 cup cream. So that's 1/2 divided by 1/4. If you recall, that means 1/2, the inverse of division is multiplication, and then the reciprocal of 1/4 is 4. So 1/2 of 4 is 2, meaning the milk is 2 times the cream. So the ratio of A to B can also be written as A colon B. That's one of those things that we sometimes use as well. So to see this in practice, we're going to take a look at a problem. Here we have the ingredients for flubber, and we want to write the ratio of cold water to glue. So we'll take the cold water, which is 3/2, and divide that, or write that as a fraction, over the glue, which is 2. But this we want to make into a simplified fraction, so we'll go 3/2. Division's inverse is multiplication. 2's reciprocal is 1/2. So we have 3/2 times 1/2, which is 3/4. So to interpret this, it means the cold water is 3/4 of the glue. So again, this is just simplifying fractions, and we're working through things based off of creating ratios and then understanding what they mean. So another way to handle ratios is through a ratio table. So two ratios that describe the same relationship are equivalent. The values of equivalent ratios are equal. You can find and organize equivalent ratios in a ratio table, and the way that we organize them is by adding or subtracting quantities in equivalent ratios. This takes a lot of thought. I rarely use this. Or multiplying or dividing each quantity in a ratio by the same number. And we'll show what that means. So here's our table. Find the missing values in the ratio table, then write the equivalent ratios. So last year, you would have had a table that looked like this. You would have had 1, 3, then put 4 there. Let's put a 6 here, and then let's put a, let's go ahead and put a 10 there. So we would have gone 1 times what gives us 4? Well, that's 4. So then we multiply 3 times 4 to get us 12. Then likewise, we would go 3 times what gives us 6? That's 2. So 1 times 2 is 2. And then you could go like 2 times what gives you 10? Well, that's 5. So you're going to multiply this by 5. And you did this last year where all you're doing is just filling in the ratio table based off of what you could multiply in order to get there. So, and remember, the question, what would you multiply by, is actually a division question. So when I'm asking, what would I multiply 2 by to get 10, I'm going 10 divided by 2. That can help out, because here we go. What would we multiply 3 by to get 12? Well, that's 12 divided by 3, which is 4. So then we're going to multiply 3/4 by 4. So 3/4 times 4, that gives us 3. Now, I can't go from 12 to 15 easily, but I can go from 3 to 15 pretty easily. Oops, 3. So 3 times 5. So then I'm going to go 3/4 times 5. So 3/4 times 5 gives us 15/4. Then, to go from 3/4 to 5/4, I have no idea. To go from 3 to 5/4, that's not easy either. But to go from 15/4 to 5/4, I think I have an idea. Because 15 divided by 5, that's 3. So I'm going to divide both by 3. So 15 divided by 3, 15/4 divided by 3 will give me 5/4. So I'm going to divide 15 by 3, and I'll get 5. Then it asks us to write our equivalent ratios out. So we have 3 over 3/4. Then there was 12 over 3. Then there was 15 over 15/4. And then there was 5 over 5/4. How much 1/2 cup of yellow mix or yellow paint for every 3/4 cup of blue paint to make 15 cups of green paint? So how much yellow paint did you use? So first of all, we need to recognize that you're not getting 15 cups of green paint from a 1/2 cup of yellow paint and a 3/4 cup of blue paint. So that's a ratio. Secondly, I want to make sure that we understand the problem. So I'm going to make the problem simpler first. This is one of Polya's little tricks, is that we can simplify the problem, do something that we understand. So let's just say the yellow is, and I'm going to make these numbers up out of the blue. Let's say the yellow is 3 cups, the blue is 10 cups. Then that would mean the green would be 3 plus 10, which is 13 cups. Well then, let's just grab a number here. Let's go with 130, just because it's easy. If we wanted 130 cups of green paint, well, to go from 13 to 130, we'd multiply by 10. To go from 10, then we're going to multiply by 10. To go from 3, we're going to multiply by 10. So 10 times 10 is 100, and 10 times 3 is 30. And if you look, 30 plus 100 is 130. So we can do this problem. So if we can do that problem, then we can do this problem with fractions. Yellow, blue, and green. 1/2, 3/4, and so we're going to add those two together first. So 1/2 plus 3/4. So that's 2, and that's 4. 2 plus 3 is 5 over 4. Now, if we look here, these are fractions. We don't really want the fractions here. We want some whole numbers to work with. So what we can do is we can multiply this by 4, and this by 4, and this by 4, because that will get rid of our denominators. So 5/4 times 4 is 5. 3/4 times 4 is 3. And 1/2 of 4 is 2. So we look, 2 plus 3 is still 5. Good. But we didn't want 5 cups. We wanted 15 cups. So 5 to 15. The way that we go from 5 to 15 is we multiply by 3. So that means that we'll multiply this by 3, and we'll multiply this by 3. So 2 cups of yellow turns into 6 cups of yellow. 3 cups of blue turns into 9 cups of blue. But we wanted, how much yellow paint did we use? Well, we used 6 cups. So these problems are the types of problems that we're working on in our assignment. They're all based on trying to simplify ratios. So real quick, I'll show you this here. You're going to simplify fractions. You're going to write them out. You're going to write these statements out as a ratio and a fraction in simplest form. Then you've got these tables here. These, I don't want to say that they're tricky. I just want to say that you're going to need to stop and think them through first. You're not just going to run through and get them done. Then on the back side, number 7, you'll use a ratio. You'll build your own ratio table. Number 8, this is just like the problem that I did last with the yellow paint. 8 has an A part and a B part. Just take your time, go through them. And then the last problem is another ratio table problem. If you take your time ask yourself the questions, walk yourself through, you'll do just fine. Thanks.